Good morning. Today is Tuesday, May 12th, and this is the final lesson of the Big Four as far as the circles rules go. I can find segments dealing with interior angles using PP equals PP. So we said yesterday the two segments rules are PP and wee. PP and wee. We said yesterday whole times exterior equals whole times exterior is wee. Do I see any exterior angles in this picture? No. So I'm not going to use the wee, which has the exterior. I'm going to use the PP. And what PP stands for is part times part equals part times part. And I'm going to explain to you what those different parts are. So I have two chords here that are cut. So this chord is cut into two parts, and this chord is cut into two parts. So basically, part times part on the left-hand side are the two parts of one of the chords, and the other side is the two parts of the other chord. So see how I kind of color-coded it here? Um, the chord that's being cut, the two pieces of them, that's what's being multiplied together. What am I talking about? I'll show you now. AE is 8, EB is 3, CE is 6. Find ED. Well, arcs and angles are segments. These are all segments, so it's got to be PP or wee. There's nothing exterior, so it's PP. So I'm going to multiply the two parts of one of the chords together on the left-hand side. Let's do this one first. The two parts are 8 and 3. So I multiply 8 and 3 together. The other one, the two parts are 6 and x. So I multiply 6 and x together. From there, I just do the algebra, and I get x to be 4. That's it. Simple rule. Let's take a look at number 2. AE is 16, EB is 2, CE is 4. Find ED. These are segments, so it's got to be PP or wee. There's no exterior pieces, so it's PP. So part times part for this chord is 16 times 2. Part times part for this chord is 4 times x. From here, I do the algebra. X is 8. All four of these rules are really simple. It's just a matter of being able to identify which rule to use and knowing all four rules, which is why tomorrow's lesson, when we put it all together, is very important. Twists. Here we go. AB is 11. EB is 5. CE is 10. Find ED. Part times part equals part times part because there are segments involved and there's no exterior pieces. So let's take a look at this. I don't have both parts. EB is 5. The other part is AE. I don't have AE, but since I have AB, I can subtract 11 and 5 to get 6. Now I have both parts. So make sure you understand the parts are the two segments of the chord that's broken. 11 is not a part. 11 is the whole chord. That's not one of the parts. The two parts are the two parts of that 11 that are cut. So part times part for that one is 6 times 5. Times part for this one is 10 times x. I do the algebra. I get x to be 3. And that's it. I think we're going to do one more with a little twist. And then after that, you'll practice on your own. Couple little geometry twists on this one. It's asking for the length of CE in simplest radical form. So that's one twist, the simplest radical form. We'll get back to that. Now, when I read through the question, there's another important piece of information that we need to use here. It says in the diagram below of circle O, chord AB bisects chord CD at E. There is a key word there. What is that key word? Bisect. What's being bisected? If AB bisects CD, if AB punches CD, CD gets punched. If AB bisects CD, CD gets bisected. So if CD is bisected, then CE and ED must be the same. So if CE is X, then ED must also be X. So that's going back to the Proust unit. Bisect means to cut in half. If CD is being bisected, and CE and ED are the same. So if CE is X, then ED is X. These are segments, so it's PP or we. There's nothing exterior, so it's PP. Let's start with part times part for this one. 9 times 8. Part times part for this one. X times X. Do the algebra. 72 equals X squared. To get rid of the square, I do the square root. Now, 72 is not a perfect square. It's asking for the answer in simplest radical form. While we did simplest radical form a lot with those Hill-Sass questions, I need to break it down into my perfect squares and non-perfect squares. I'm going to list my perfect squares. I'm looking for the largest perfect square that goes into 72. Can I divide 72 by 64? No. By 49? No. By 36? Yes. 36 and 2, that's step 1. Take the square root of the perfect square. Your answer is 6 rad 2. So could this reducing radical thing come up in the question? Yes. Is it going to come up every time in a PP question? No. But in geometry, you might see other concepts mixed into a question. So this was the last one. I wanted to throw a couple little extra geometry twists at you, but the understanding of this lesson is simple. When you have segments and everything is inside, PP equals PP. That stands for part times part equals part times part. So we spent 4 days on 4 simple rules. It's important that you know all of them. And tomorrow is a very important lesson. Nothing new in tomorrow's lesson, but in tomorrow's lesson, we're putting everything together, all 4 of these rules. We have to determine which rule to use, and we have to know all 4 rules. And there's a song in tomorrow's lesson, a really good one. So I look forward to that. Ask me any questions if you have them on Remind, your classwork/homework. Is to finish the worksheet, and your quiz is going to be due tomorrow. You may or may not have noticed, but I actually just recorded 4 lessons in a row. I did your big 4. I did your 2EA, your 2VA, your WE, and your PP back to back. It's actually not May 12th. It's actually May 6th. And I just banged them all out now, so they're done because they're short little lessons. I'm going to wait some time to do the next lesson because that's really important. That's where we're putting everything together. And, it's good to get ahead and not wait till the last minute to do everything. So, kind of modeling that behavior for you. Any questions, reach out to me on Remind, and enjoy the rest of your day.